7.4 is all about quadratic equations and functions. And we're going to talk a lot about these differences, as well as beginning to answer the question of zeros and talk about how we can begin to use this in a more applicable way. So before we get on to equation versus function, let's look at zeros. The kind of very beginning of the year, I mentioned that zeros had several different names. Another one was roots, x-intercepts, and lastly was solutions. And solutions, zeros, roots, x-intercept, that simply means where does the graph cross the x-axis. That's what we're looking for. Where does the graph cross the x-axis? And that point or points is going to be our zeros or solutions. And that's it. So now let's look at equation versus function. An equation would be something like ax squared plus bx plus c equal to 0. Because it's set equal to some specific value. A function is the entire set of values. In other words, f of x equals ax squared plus bx plus c. So the difference between this and this, the equation says that this has to equal 0. That's where we're getting these zeros from. Y equals 0. Remember, when it crosses the x-axis, y equals 0. So that's what this is saying. Function equals 0. Y equals 0. Y equals 0 in this case. Here, though, it's saying, hey, here's the function, here's what it is. If I was to graph this, it would look like this, some U shape. I don't know exactly what it looks like, where it crosses the axis. Now, this is testing these exact values of y. Y equals 0. These 2 points here are being tested by this. The function is every y value. Okay, so that's the difference. This is all y values. This is a specific y value. So this brings me to the question of how many zeros can we have for a specific quadratic function? Well, in this case, there are 1, 2. Okay, great. Well, what if it looks like that? There's just one solution, but it's called a double root, where it bounces at the root. And lastly, we have something that looks like this, where there is no touching of the x-axis. So it doesn't touch the x-axis at all in this case, and that would give us an example of imaginary roots. So 2 real roots, 1 real root, or 2 imaginary roots. Okay, I apologize for the video being cut off down here a second ago. That last example is if a function looks like this, where it does not cross the x-axis. So that would be an example where there are imaginary roots. And so now what we're going to do is we're going to look at some examples algebraically to see what makes imaginary versus real, those kinds of things with algebra and not just the picture. So the first example I want to look at is 2x squared minus x equals 3. Okay, so I want to look at this example. I've kind of written them over here so I can remember. I want to move this over. So I'm going to solve this equal. to 0. Okay, and remember we have a times c, which is 6, and we want that to equal -1. So, what are the factors of 6 that could give me -1, 2, and -3? So I can rewrite this 2x squared plus 2x minus 3x minus 3. What are the first two? What are the second two have in common? These have 2x in common. And what's left? X plus 1. These have negative 3 in common. And what's left? X plus 1. So x plus 1 is the same. And so we have 2x minus 3, x plus 1. And from here, I apologize, I didn't write equal to 0. And now we set both of these equal to 0. And we did a lot of this practice before, so I'm going to skip setting them to 0 and just do that trick we learned where we can change the sign. So that would be x equals 3 halves, x equals negative 1. Okay, so that's how we solved these. Now, this gave me how many roots? It gave me 2 real roots. Those are both real numbers. So I know that this problem has 2 real roots. And so if I was to look at the graph of this, I would expect the roots to go through 3 halves and negative 1. So if I drew a graph, negative 1, 3 halves, should look something like that. Okay, next example. 2x squared minus 10 equals 0. Okay, what I'm going to do here, instead of, because I only have one x piece, instead of doing a squared times, or a times c, and then finding the factors, I'm just going to move this over, and I'm going to get 2x squared equals 10, x squared equals 5, x equals, now here's this thing that we have to remember. When I'm taking the square root of a number, I need to do the positive and negative of that value. So plus or minus the square root of 5. Okay, is 5, square root of 5, a real number? Yes. So even though it's irrational, it's still a real number. And so this graph is going to look something like this. There's a point on both sides that are equal distance. How do I know? Because one is positive, one is negative of the same thing. And goes like that. Okay, so if you have a problem like this, you do not have to do a times c and figure out the middle piece. You don't have to worry about that. All you need to do is move things over and solve for x. Okay, another example, maybe x squared minus 6x plus 9 equal to 0. So in this case, I can't do this trick, right? I have an x in the middle. I have an x in the middle. So I have to factor. Okay, well, what adds to, or multiplies to positive 9, but adds to negative 6? Well, that would be negative 3 and negative 3. Now, these are the same thing. So if they're the same thing, I only need to solve for 0 once. So that's x equals 3. And so how many roots does this have? 1 double root. Why a double root? Because there are 2, but they're the same value. So even though there's 2, it only occurs at one position on the graph. And so that would look like this, where it touches one time. So we've done 2 examples where it has 2. One example where it touches once. Let's do an example where maybe it doesn't touch at all. Okay, an example where it doesn't touch at all, something like x squared plus 13 equal to 0. Okay, x squared plus 13 equal to 0. Let's follow the method that we did before. So I'm going to solve for x. X squared equals negative 13. X equals positive and minus. Anytime we take the square root of a number, we need both. Square root of negative 13. And we have then that x equals positive I square root of 13 and negative I square root of 13. Now, the positive and negative is coming from here. Positive, negative, that's those 2 pieces. But where did the I come from? Negative inside. Remember, negative inside is I on the outside. So negative on the inside, I on the outside. So I broke this into its two pieces and then moved the I out. And so that's all that you need to do whenever you have simple problems like these, where you can solve for x or you can factor into the pieces that give you the zeros. In this piece of 7.4, we're going to look at something called the quadratic formula. The quadratic formula will work 100% of the time when you have a quadratic equation. So it makes it better than factoring. It makes it better than solving for x, because you can use this formula 100% of the time and it will always give you the zeros. Whether they're real, irrational, rational, imaginary, it doesn't matter. This quadratic formula will always give you the correct answers or the correct zeros for a function. Now, a lot of students, when they see it, don't really want to try to memorize it and say, man, that thing is too long. But since it works 100% of the time, you don't need to worry about all of the different and other methods that are out there if you can just do this one method. And I'm going to save you the time of me doing the proof. You can look the proof up on YouTube. You can look the proof up on your ebook in my math lab. And the proof shows where the formula actually came from. So we're going to say the zeros, which are x values, are going to be equal to negative b plus or minus the square root of b squared minus 4ac, everything, don't forget this first part. That's the most common mistake I see when dealing with students, is that they forget to include negative b here, all divided by 2a. Now, this is rather interesting use of algebra. Somebody took the original function, solved it, and created this. And so it does work. And so just to kind of show an example of this, if I have a function, f of x equals 3x squared minus 5x plus 7. Okay, I've just picked random numbers. They just happen to be 3, 5, 7, but that's fine. So first thing I'm going to do, I'm going to write down my A, I'm going to write down my B, and I'm going to write down my C. It's always A, B, C. Remember from the previous video that quadratic functions are f of x equals ax squared plus bx plus c. So if I have a negative, I have to include it. Okay, so now everywhere I see a in this function, I'm going to replace it with 3. So I have minus 4 times 3 all over 2 times 3. So I've replaced the 2 a's with my 3. Okay, that's it. Now b is negative 5, so I need negative 5, and then negative 5 squared. Okay, and lastly c times 7. Okay, so let's look at this. Negative 5 is 5, plus or minus. Negative 5 squared is 25. And 4 times 3 is 12, times 7 is minus 84. All over 3 times 2 is 6. Now, here's where in a minute we're going to talk about this thing here, the discriminant. We're going to talk about how I can use this to tell whether it has real solutions or imaginary solutions. And so what I'm going to do now is I'm going to take 25 minus 84. So 20 from this would be 64, so 59 minus 59 all over 6. Now, does this look nice? No, it doesn't look nice. And this is a negative on the inside. So what do I have to do with a negative on the inside? I have to make it what on the outside? An I. So I have 5 plus or minus I square root of 59, everything divided by 6. If I have an I, is this real or imaginary? It's imaginary. So there are two plus and minus imaginary solutions. So now you can kind of see how this thing, this determinant can tell us whether or not we're going to have real or imaginary solutions. So the quadratic formula is extremely useful. It works 100% of the time. Now, let's look at the determinant. Okay? The thing that I'm going to box in red here is called the determinant. Okay? This is the determinant. Okay? And that determines whether the function will be real or imaginary. So let's look. If the determinant, we'll just say if the determinant D is greater than 0, if this thing is bigger than 0, will it have real or imaginary solutions? Well, if it's bigger than 0, is it negative? No, it's positive. So another way of saying this is if the determinant, this thing here, is positive, b squared minus 4ac is positive, then it's real solutions. Real solutions. If b minus 4ac equals 0, it's still real solutions, but only one real solution. If b squared minus 4ac is less than 0, it means it's negative. And if it's negative inside of a radical, that means it's imaginary. It will have an I. Okay? So it's important to remember this thing here. It's imaginary if the determinant, this inside piece here, is less than 0. I do want to mention quickly that there is this kind of very interesting idea where we could substitute in a u and solve things that are not quite quadratic. For example, x to the 4th minus 5x squared plus 4. X to the 4th is really x squared squared. So if I have x squared squared and x squared, I really have a quadratic type function. So if I let x squared equal u, then I can replace these values and get something that looks more like what we've done something with before. For example, u squared minus 5u plus 4 equals 0. Well, x squared is u. I said that, so this becomes this. But u squared is from x squared squared, so u squared. Now I can treat this like any other quadratic function. I can factor. Okay, what multiplies to 4 but adds to negative 5, I believe that's negative 1 and negative 4. Right? Negative 1 times negative 4 is positive 4. Negative 1 minus negative 5, negative 1 minus negative 4 is negative 5. And so that tells me that u equals 1 or u equals 4. 1 from this one, 4 from this one, because I set these both to 0. But what was u? U was x squared. So that means I really have x squared equals 1 and x squared equals 4. So how do I get rid of the square? I square root both sides, but don't forget, when I square root a number, I need positive and minus of that. So x equals the positive minus square root of 1. But what's the square root of 1? Just 1. Down here we have x equals the positive minus of the square root of 4. What's the square root of 4? 2. So we have 4 answers this time, positive and negative 1, positive and negative 2. And that makes sense because what was our power? 4, so we should expect 4 results.